Hey guys, my name is Kumar. This is my extra credit video for Physics 2. It's going to be on the lecture by Tom Murphy on estimating our energy predicament. In the lecture, Tom Murphy he used these methods of estimation to basically show that our what our energy needs are, what our demand is, ways we can try to meet those demands. Um, he used this method of estimation where he came to the same conclusion as the Keelan curve does, which shows the CO2 concentration per year, which has been increasing by like 2% per year. And he went through this process of estimation, like how much CO2 is in the atmosphere and so on, and he like the weight of CO2 density or whatever, and he came to the same thing, that it rises about 2% a year, which is very close to the Keelan curve, and he went on to just estimating like energy usage, what we need, ways we can store energy, how much energy we can store, those various ways. For example, he tried to he estimated how much energy we would generate using all of the coastline in the world, use it by wave power, and if we were to utilize every single part of each coast on every continent in the world, we would only meet 1% of our global energy demand, which is pretty surprising. And that was just an example of one of the many surprising things he talked about during his lecture. The whole thing, what really got me was the method that he used to get to his conclusions, or his numbers, like that 1% of global energy demand, and he basically it was he in the beginning of the lecture he used these Fermi problems, which require estimations, and they typically are like real world problems, where you are given just a problem statement and no numbers or anything, and you're just left with making judgments for yourself. So I thought it was really interesting. He recommended this book, Guesstimation, which is full of Fermi problems. And one of the problems here is, I'm just gonna do one real quick to show you what it's like. One of the problems here is, like, if all the pickles sold in the U.S. last year were placed end to end, what distance would they cover? So that's the problem. That's the problem statement. The first step, basically, you want to think about what information you need, and this information isn't given to you, so you have to just come up with numbers on your own. So it says U.S. How many pickles sold in the U.S. last year? Placed end to end, what distance would they cover? Okay, so first of all, you need to know how many people are in the U.S., how many pickles they buy per year, and the length of one pickle. So let's see. Another thing that was interesting was, he said, as long as you're estimating within one order of magnitude, your answer should end up being roughly correct. If your answer is within a one order of magnitude, it's correct, or it's correct enough. So let's start. I know there's 300 million people in the U.S., so it's 3 times 10 to the 8th people. And let's see, a pickle is definitely more than 1 centimeter long, but definitely less than 100 centimeters. So let's say 10, 15 centimeters, go 12 centimeters. And what else do we need? We need to know how many pickles on average do people buy per year. Let's see. Let's go with, it's definitely, I said it's definitely more than 1, less than 100 maybe. Let's go with 20. Okay, it's 20. If I plug all these numbers into my calculator, give me 1 second. I get I get 7.2 times 10 to the 10th centimeters, and that's the distance you would get if you placed all these pickles end to end. And their answer here is 6 times 10 to the 8th meters, which is 6 times 10 to the 8th centimeters. 6 times 10 to the 10th centimeters, which is very close to mine. I have 7.2 instead of 6. It's very close. And yeah, it was just one of the easier problems in the book. It's really interesting how you can come up with these answers just by making like simple guesses, simple estimations, just guess. And as long as you're within an order of magnitude, it's good. And that's it for my video. I just wanted to share with you the Fermi problems and that method of estimation is really powerful.